Welcome here to the Metcalf DiPasquale Show. Yes, we are back, and I got a great interview today, Carson, with an astronomy physics professor, right?
Fascinating topic, too. Something that I don't really think is being talked about a lot, right?
No, it's very, very interesting topic,
Yeah.
and we hope you enjoy it. With us, we have Dr. Kanbur from SUNY Oswego. Yes, how are you?
I'm fine, thank you. Nice to be with you.
Yes, thanks for joining us.
Yes, thank you very much.
My pleasure. Yeah.
And John and I know we've been talking about this throughout the morning. Very fascinating topic today. The topic is a company called Reflect Orbital, John, right?
Yes.
Looking to send first test satellite into space at this point. The FCC has approved them to test one satellite at this point with potentially an eventual plan for thousands of satellites. The main object being reflecting the sun's rays back down to Earth. In other words, lighting up a large area of 3.1 miles, John, right?
Yes,
right?
3.1 miles to the further test coming up here soon, fairly soon anyway, and it's going to be done in Southern California. Correct, Dr. Kanbur?
Yep, 24 square kilometers. That's roughly the area of the Earth's surface that they plan to illuminate initially. Yeah.
And essentially with the idea, I mean, basically this is effectively to sell sunlight at night, right? Do we have that kind of the idea there, correct?
Generate energy. Yeah.
Okay.
Yeah.
So it sounds like a fascinating idea, but when you really kind of peel back the layers here and look at this, I mean, could you speak to, this is one, just want to be clear, this is one test, one satellite that's going to go up. The company eventually would like to put up 50,000 satellites by 2035.
Yeah.
Speak to, if you could, just baseline impacts. I mean, pros versus cons. What does this do for us, in terms of impacts?
So the first thing I'd say, it's not a new idea. It was actually postulated back in 1923, so almost 100 years ago. The idea of putting sort of mirrors in space and reflecting that sunlight. Obviously, the need for energy is very important. Need for sustainable, clean energy is important. So from that respect, anything to do with solar power, I think, deserves further consideration. The initial sort of estimates which I've looked through suggest that the initial mirror will generate about 0.04 watts per meter squared, and sort of the brightness that you get will be roughly what you see on a full moon. So you do really need a lot of satellites in order for this to make a substantial contribution to energy generation. So you need something of the order of tens of thousands of satellites in order to get up to something like 200 watts per meter squared.
Wow. Which would be, what equivalent would that be if you had the 50,000 that they're projecting to try to put up into
so if you had about 50,000 satellites up there, similar to the one that's supposed to be going up, that would be about 200 watts per meter squared. So that could be, heat a few thousand homes, and perhaps tens of thousands of homes, perhaps.
What kind of light would that cast?
So one of these satellites, that would, like 0.04 watts per meter squared, is sort of like the light of the full moon, if you can think of that. So 200 will be a lot more than that. That would be for energy generation. That's not necessarily saying that those beams will be lighting up. They'll be lighting up solar panels on the Earth, put in specific locations, and the output that you get will be about 200 watts per meter squared. So 200 watts per meter squared, that's about like 15 to 20% of the noonday sun.
Wow,
so
that's quite a bit.
Yeah,
that's quite a bit.
And in certain areas you'd see that, not everywhere, but that's roughly what you'd see.
Go ahead, I'm sorry.
That's assuming everything goes according to plan. Remember, this is just the first test satellite. And there are lots of cons to this as well.
Right. So the pro is, you're going to be able to maybe heat some homes more so
correct.
with it.
Yeah.
Maybe
some
energy.
Areas need some emergency lighting at night. Maybe you could use it to make crops more efficiently, grown more efficiently. Perhaps that's some of the sort of pros about this. But I think there are a lot of cons which also need to be addressed. And
Considering,
I just point out that there was an actual a town in Italy. I was doing some research for this called Vignella. This and another town. They don't have any direct sunlight because of their geographical location and steep mountains. So they actually constructed a mirror on the side of the mountain to reflect the sunlight, so that their town in particular gets some more direct sunlight.
For
Not
like depending
necessarily
how big
for
the mirror
power
is, right?
generation, but just to feel good, just to feel better about it.
It's good for health, right?
Yeah,
For health.
just to feel better about things.
A little extra vitamin D.
This idea has been around for a while, and there are lots of and so on. So, but nevertheless, the cons would be, from myself as an astronomer, I think it's hard to get around the fact that there will be a lot of extra light pollution, which would severely affect, lots of professional grade telescopes around the world. There's one in particular called the Vera Rubin telescope, which has just been launched. That's one of the probably one of the most ambitious astronomical research projects for a long time. It's going to make essentially a movie of the entire sky every day for the next 10 years. It's an enormous project. The whole astronomical community is really geared up now to get the benefits of this project over the next 10 to 15 years. And obviously, the quality of the light that you get in an astronomical image depends on it being dark. So anything that affects that, will reduce and in some cases make the astronomical images unusable. Even, many times you can't even observe, or at least the images that you get on a full moon, on a night of a full moon, are obviously not as good as if you get a new moon or no moon. And they would also, reduce the quality of those images. What could be done with the science? That's a big concern. Particularly if you've got something like 50,000 satellites, that's going to be really difficult to track. I mean, the company has stated that, they're to be commended for that. They're going to talk with scientists and astronomers and coordinate extensively with that. But I just find it at the moment hard to see how 50,000 satellites in the air or in space around us would not seriously affect operations of many serious astronomical research grade telescopes.
Yeah, and Dr. Kanbur, let's put a scale on that, right?
Yeah.
Because right now we've got roughly 18,000 active satellites. So
Correct,
we're talking about adding to that 50,000, tripling, right? Effectively. I mean, talk about. Let's set the impacts, pros and cons aside for a minute. Let's just talk about the sheer number of satellites. I mean, obviously space is space. We're talking low orbit, right?
Yeah.
So,
Yeah.
I mean, what are we going to run out of space? Are we going to be worried about collisions, things like that?
Space junk crashing to Earth.
Well, already, space junk and so on is a bit, needs to be monitored very carefully when you send a new satellite into space, or when you send when NASA sends a space mission. So if you triple that number, obviously it's going to make it much, much harder to coordinate effectively the movements of all of these satellites, and even the mirrors. So even the mirrors of these satellites, they're going to, at the altitude that they're planned, they will suffer quite a few collisions from millimeter, centimeter size objects, space debris, and that can also degrade the efficiency of the mirrors and so on. So it's definitely a technically very challenging project, and I'm not so sure at the moment whether the benefits will be significant enough to warrant such an effort. And then there's also the sociological aspects of this. We as a species have grown up with the 24-hour day, night, day cycle. Plants, animals are really accustomed to that cycle, and I think not enough is known about what would happen sociologically and biologically if we disturb that cycle, as might happen in this case.
So those mirrors you were mentioning, they could be damaged by little pebbles
Yeah,
or
yeah.
little meteors.
Space debris. Yeah.
Yeah, space debris.
Yeah.
I imagine they have them. They're planning on having them, or they are coated or protected, the mirrors, to be able to take a little bit of a beating.
I'm sure they'd have to be. That would, of
They have to
course,
think about that.
add to the weight of those things. It would make everything else a bit more, like putting those into orbit, a bit more expensive. But nevertheless, you can't protect it 100%. You can't protect those mirrors 100%. There's going to be a certain loss over time because of this space debris, which will only increase as time goes on.
Are you concerned also, Dr. Kanbur, of, I know probably top level astronomers and the government is keeping an eye on asteroids that, maybe near Earth, possible Earth striking. That is going to pollute that too and block our view. And there could be one coming. I mean, on a grand scale that could wipe out the planet. Obviously, it's happened before. And
so that is an important consideration, and such a large number of satellites in space would obviously make detecting these potentially hazardous asteroid orbits a bit more difficult, right? Not a bit, quite a bit more difficult, because you'd have to screen out these other things. So you'd have to keep very close track of all of these satellites and all of this space debris, and obviously that makes that harder. So that is a concern as well.
So are you surprised, given the planned or intended scale that Reflect Orbital has, that this was given? I mean, granted, we just want to mention it's one test satellite at this point, but are you surprised that it was granted FCC approval?
To some extent, yes, I am. Yes, because I think I read somewhere that the FCC, the various objections that various members of the astronomical community raised, the FCC said that those objections were outside their scope. So it sort of raises a question: well, what is inside their scope?
It's what they do. This is what they do. Hello.
Right. Yeah.
Sorry.
So that was somewhat surprising to me, and let's see what happens. I don't know. Maybe this satellite they'll solve all of these technological problems, and it'll be a great benefit. But then also, part of me says selling sunlight seems a bit of a I don't know.
Sun subscriptions.
Right. As someone here put it.
Somebody else saying that.
That's just me. But obviously we do that on the ground because we have solar power stations and they sell the electricity. But I don't know. Okay, maybe that's where we're heading. But it was very surprising to me that this was granted permission to go ahead.
It seems like they're kind of in the minutia of, okay, what are the frequencies and what, sort of the technical side of it, and sort of sidestepping the impacts that you mentioned, rightfully so.
When is this? So they approved the one satellite with the mirror and the 3.1 mile space in Southern California just to test it. When is that test supposed to happen? And when, if it goes well and they deem it okay, it's safe, we're gonna ignore some of the cons potentially and do it in the 50,000 satellite scale.
So
when is that supposed to happen?
I think this permission by the FCC was only for this one test satellite. So I presume that this launch and test will occur in the next couple of years or very soon now, so I guess we're talking, if that goes well, we're talking something like in the 2030s, something like that. That the plan for these 50,000 satellites, if that is approved, will go ahead at that time. That's stuff. I think that's the time scale that we're talking about.
Yeah, I thought I saw something. I was telling Carson this before we started this show just a little bit ago. I thought I heard 2035 was a goal.
That's
anyway.
the goal. Yeah. You have to have all 50,000 should it be approved eventually. Yeah.
Right. One of the articles I was reading there.
Yeah.
I just find 50,000 satellites in orbit. That's going to be. I think a lot more research has to be done on the various aspects of putting such a large number of artificial satellites in low Earth orbit. And I think it involves a lot more agencies than just the FCC. That's what I would have thought. Yeah.
Well, this has been a fantastic discussion. We're gonna resume it, but first we'll take a quick break and then come back.
Okay.
Stay with us, everybody.
Cheers.
We're back here, the Metcalf DiPasquale Show. We have a fascinating topic today. We're talking with Dr. Kanbur of SUNY Oswego, professor in astronomy professor there up at Oswego, and we're going to have him join in again here. Really a fascinating topic about space mirror that was approved by the FCC recently. That's going to be sent up into space on one satellite and then casting sunlight on about a 3-mile surface spot in Southern California, or an area, 3.1 miles. So we've just been discussing that, Dr. Kanbur, with you and your concerns of, on a grander scale, how that could affect astronomers trying to see, and map things in space. And then we haven't really talked about the meteorology part of it. And Carson and I definitely want to obviously talk about that with you, being that we're meteorologists.
Right.
So,
I would say that the Earth's atmosphere is a complicated system. There are many inputs into the way the Earth's atmosphere behaves, and the Earth's sunlight is one of those. The sunlight from the sun is one of those inputs, and if playing around with that at the level of 50,000 redirects, let's say, I don't know, it seems that a lot more research has to be done as to what are the potential effects on the Earth's atmosphere occurring because of that. It's impossible to say that there'll be none, or with certainty, I don't think you can say that there'll be none if you go to that level. 1 or 2 satellites, okay, but 50,000 satellites, each redirecting sunlight to a particular area on the Earth's surface, that needs to be investigated further. What are the potential effects of that?
Yeah, definitely a little concerning, I'd say. I mean, if you put 50,000 satellites into space, that's inevitably going to block some sunlight from getting into spots on Earth, parts on at different times. And then if you're redirecting it in spots it's not supposed to be, and at night, say you're casting sunlight on a spot that's supposed to be dark, differential heating across parts of the across the planet. That's going to cause animals, and you said the biology, of creatures,
circadian rhythms.
Yep, that's it.
So you said actually that on the grander scale, astronomers are concerned, but I think the grander scale is actually the sort of bio-sociological aspects of being able to redirect sunlight at our will, right? I think is a very dangerous power, so to speak, to have, and in order to wield it, we must really be able to understand the implications of that on many different levels, not just on the biological and physiological aspects on flora and fauna, but on the sociological aspects on humans. We've grown, as I said, we've sort of evolved with this 12-hour day, 12-hour night type cycle.
Yeah.
And our physiology is also adapted to that. And if we start changing that, I don't know, it needs much more study to really understand what would happen. What are the possible implications?
And then the precision with which this has to be done too. I mean, I believe I read you're talking about repositioning each, each reflection every 4 minutes, I think.
Yeah, because of the rotation of the Earth.
Right.
You're trying to keep up.
You have to, so at the moment with the one satellite, you'd only be able to direct the spot at one particular location for 4 minutes, as you say. So
yeah.
I don't know.
That's incredible.
It's a huge technological problem, but I think even bigger than that are these broader implications. So the implications for professional astronomers are, okay, that's of interest to me, but I think there's a lot of wider interest for everybody as a whole on these other sort of broader aspects of such a technology.
Even as simple as you think about driving at night, you think about a pilot taking off at night. I mean, how is there going to be a guarantee necessarily that that light won't scatter? And exactly. Just given
Blind's a pilot.
Yeah. I mean, there's so many. You bring up the biological, sociological. I mean, even just something as simple as as simple as a flight taking off.
Well, there's some studies which have suggested that even if somebody just randomly using their binoculars on the ground or looking through a small amateur telescope, going through these beams, it might cause some damage to your retina.
For sure.
So,
similar to staring at an eclipse,
right? Exactly.
Right,
which is we got that's it's so many great points, and then. Here's another thought on it. So if you're redirecting sunlight to get sunlight in one part of the planet, right, to help one part of the planet, when you redirect and deflect the sun, there's a part of the planet that's getting less sunlight, right?
Although that would, I think, perhaps because it's sort of like sometimes you have large astronomical mirrors with there's a hole in the middle, right? That doesn't really affect the image as a whole. I don't know about whether that would be, well, perhaps with 50,000 things.
Yeah, that's
it
many.
Might be. With one, it's okay. One or two, it's okay. But with 50,000, I think that might be an issue as well.
Even if it's only a degree or two, right?
Correct.
Yeah. It's that trickle down effect, snowballing. Yeah. 1 or 2 degrees can make it, trickles down and causes something to be more grand as far as the effects down the line.
Yeah.
So many questions. I mean, I know
wild to think about.
I mean, I love the energy part. That's fantastic. And if there's a big rescue going on, they want to cast some light at night, to help. But I think the impacts.
So
biologically.
There was an interesting thing. I've forgotten who suggested this, but there was a suggestion that the mark of an advanced civilization is when they can control the energy from their host star. So if you're an advanced civilization, if you can control the energy of the star that your planet is orbiting around, outside of will. So in some sense, this is interesting because this is starting to get to humanity's attempts to try to do that. So we're far from an advanced civilization when you consider this metric, but it's kind of interesting that this is like our attempts to try to get to that. So it's a very laudable attempt to control the sun's energy, because that, just as I always say this to my Astronomy 100 students, the sun's luminosity is roughly 3 times 10 to the 26 or 27 watts. That's the energy it radiates per second. So if you could capture 1 second of the total energy radiated by the sun, just in 1 second, right? So that's something like 10 to the 26 or 10 to the 27 joules, and keep that in a battery, some giant battery. And then everybody's energy needs would be satisfied by just essentially plugging into this battery. Everybody on the Earth, whatever the factory, your laptop, your cell, cars.
Never have to recharge.
Everything.
That's it.
You don't have to recharge. But the question I ask is, how long would that battery last? That battery would last for 500,000 years, even allowing for, our exponential increase in energy needs. Wow. That's how much energy.
1 second of the sun.
Just want the total energy radiated by the sun in 1 second. If somehow we could capture that and store it in a battery, and then everybody on Earth, their energy supply, you just plug into this battery, whatever you're doing, a factory, your house.
A universal battery.
Yeah. That energy would last for 500,000, roughly 500,000 years. So it's the ultimate thing.
Mind-blowing.
To use the sun's energy, and maybe it's a mark of our progress as a civilization, humanity's progress to try to get to that point. So, but I still think there's a lot of work that this particular project has to do to allay some of the cons that we've discussed today.
Right. It's incredibly profound.
It is.
Thought.
That thought is wild.
Yeah.
It's crazy.
And
gonna sit with you for a while.
the sun is a very average star. It's
Yeah.
not at all. It's very a C student, completely a C student.
Wow. This C student, though, has got lots of punch. So,
For us, yeah.
right, for us, for planet Earth.
Yeah.
Wow.
Well, Dr. Kanbur, it has been a true pleasure spending time with you.
Thank you very much.
Thank you very much for the time and all this great information you gave us, and for us to ponder here, Carson and I, and our viewers to ponder as we get closer to at least testing this here soon, within the next year or two, and then we'll see what happens after that first test, I guess, right? And we may have you on again. May have you on again to talk about how things went. And
I was going to say, I suspect this is probably not the last time we'll be talking on this subject with you. So thank you very much. We really appreciate it.
Cheers.
Thank you very much. Take care. Bye.
Download the WSYR Plus app on your TV to stream News Channel 9 for free. Just go to your smart TV, search WSYR Plus in the App Store, and download to start streaming today.